Yes, very good afternoon to all. Today it's the fifth day of our FDP. So we have three sessions today. First is IoT Security Issues and Solutions by Dr. Himanshu Agrawal sir. Second one is the Research Challenges and Opportunities in IoT by Dr. Chaware sir. And third one is the Applications of IoT in Healthcare Sectors by Dr. Parle sir. Okay, so I can give the session to the Sarita ma'am for further. Thank you so much. Thank you.
Thank you, Asma ma'am.
Yes, yes, you are audible. You
I
can start.
welcome our speaker, Himanshu. Let me give you. Sir is working as associate professor at Swinburne University of Technology. Sir is having expertise in multidisciplinary research. His area of interest in the IoT sector, privacy preservation analytics, blockchain, AI, artificial intelligence, and machine learning for network traffic and cybersecurity. I would like to say thank you to Himanshu sir for accepting our invitation, and I'll ask sir to carry ahead the session further. Thank you, everyone. Himanshu sir.
Okay. So good evening, everyone. First of all, I thank this team from MMCOE working so hard, and a special thanks to Dr. Sandeep, who has given me this opportunity to present on this important topic on security and privacy issues in IoT applications. Of course, I mean, I have some specialty areas such as networking, but security and privacy is another area of my research focus in the past 4 to 5 years. So quite recently, I have supervised one PhD to successful completion on this topic. So I thought that this could be quite useful for some of you who are either pursuing PhD or who are doing research in this domain. So let's begin with this important topic on security and privacy issues in IoT applications. Okay, so if you look at this growth of IoT, so there is one white paper by Ericsson. So if you get a chance, you can have a look to this paper. And Ericsson has given some estimated figure of how IoT has seen a growth. I mean, there are multiple estimates, starting from Cisco's estimate of 50 billion devices in 2020, which is going to grow by another 50 billion. And this figure is going to rise up to 100 billion devices by 2025. Right. So in this slide, I'm just referring to one of these estimates by Ericsson, and based on the white paper which I have referred. So if you see that the growth in the number of connected devices is around 21% every year between 2016 till 2022. It's estimated, right? And another important thing which you must have studied or which you must have noted so far for all IoT systems, that we have multiple IoT ecosystems, right? And within IoT, I mean, you have seen the heterogeneity as well, that some of these devices are static, whereas the other devices are having mobility aspect, right? For instance, autonomous cars, right? So there is a wide range starting from static constraint sensor devices to autonomous vehicles. Now, one important thing when we see all these devices hooked up to this internet and forming a huge network, a huge internet of billions of such devices, we believe whatever information we communicate through that device should be a part of trustworthy platform. That's how the internet is designed to be, right? So the design philosophy behind internet is that internet is definitely is a trustworthy platform. So which means that if you have these billions of devices now connected to internet, you are aiming for end-to-end security, right? So IoT therefore needs to be secure. So let's move on from this the fundamental requirement of the IoT platform needs to be secure, starting from device level security to end-to-end security between two devices connected on internet platform, to the security aspects at other points as well, such as the security at the data aggregation, right? So where you have a gateway node or data aggregator node uh, having aggregation of data from multiple sensor nodes, right? To the security issues on the cloud side, right? As well as the privacy issues as far as the information is concerned, right? So if you look at this broad picture of security in IoT, one thing is clear: whether you talk about smart home application or whether you consider connected cars as another example, right? Healthcare application. So you see that for all such applications, you have devices which are connected to the internet, and we have seen an unprecedented growth in these devices in the past few years. And we are going to see a growth in the next 5 to 10 years as well, right? So as I said, the security and privacy both are important when you are trying to enjoy the benefits of IoT. At the same time, you have to be ready to address the challenges on part of both security as well as privacy, right? Now, if you take a look at this important data provided by telecom TV, right? So this data shows that um, I mean how you have got the IoT security spending compared to the device growth, right? So starting from 2014, so the data is little old. So for this 5 years data, if you have a look from 2014 till 2018, so there is a growth from 3.8 to 11.4, right? Whereas if you see on the right hand side, the worldwide IoT security spending in millions of dollars, so it has increased from $231.9 million to $547.2 million, right? So the growth in device, if you compare the growth of devices and if you compare the security growth, there is still a wide gap, right? So you can see that very clearly. So yeah, so I think that there is a huge scope here in terms of developing security solutions as well as working on privacy issues. As I indicated, that privacy one of the important challenges in IoT applications, particularly a healthcare application, smart grid application, right? So in my discussion today, I'm going to consider one case study in detail, right? So you will have a complete idea of how this privacy preservation in one application, one IoT application can be addressed. So in the broader category, if you see the segmentation of this IoT security challenges, it is basically in the form of authentication challenges, right? So you have authentication as one of the important challenges. You have access control, privacy, as I said, trust, policy enforcement, mobile security, right? Secure middleware and confidentiality, right? So some of these challenges, I think I'm not going into the details of this. These are the fundamentals relevant to uh, a general security, right? So whenever we talk about a broader security umbrella, this is how the security covers all these aspects, right? So when we talk about these IoT applications, of course, we can cover some of these challenges, and I can cover five from this IoT security, this circle. having different IoT security challenges. So I'll cover first the cyber security for billions of devices, right? Now, if you see the forecast from the Gartner, more than 25% of all enterprise attackers are estimated to attack industrial IoT solutions. So in the past few sessions, I think you have already attended a discussion on industrial IoT, Industry 4.0. So as we have seen that there is a growing interest on Industry 4.0, particularly for saving cost, right? So, I mean, if you look at the security and the privacy aspect for the Industry 4.0, so there is like an equal challenge on part of uh, this what you call cyber security, right? So yes, if you see here industrial IoT, you have autonomous systems, autonomous control systems, right, performing their task, of course, by having collaborative communication between sensor nodes. So it's like a fully connected um, you know uh, automated system, right? Now, when you have such connected and autonomous control systems in Industry 4.0 setting, these devices or these sensor devices working in such setting, they are vulnerable to distributed denial of service attack. So in my previous discussion, I think somebody asked me about, uh, I mean, there was a question on this security aspect. And I think now in this session, you will have more on this. So distributed denial of service is is not a new kind of attack, is like a well-known attack, especially when we are working in this era of internet, right? So when these devices are connected to internet, distributed denial of service, or when we talk about a distributed network, this distributed denial of service attack is quite important, and most of these security solutions are definitely having lots of challenges for this distributed denial of service attack, right? So in which attacker can actually create an army of many devices, many bots, which we call in the language of security, right? So yes, IoT devices are easy to hack, and one such attack is distributed denial of service attack, right? So this is one good area if somebody is providing, a security solution for distributed denial of service, right? So IoT security solution for distributed denial of service. Now, privacy and information security in IoT. Now, we talk about privacy, right? So privacy has been discussed quite widely, as I said, over the years, both by researchers as well as media persons. In fact, media persons have made privacy uh, look more important, right? And quite recently, we have seen, uh, some examples. Facebook, right, is one such example where we have seen privacy as a big issue, right? But I think despite having such issues, we enjoy getting benefits, right? So if we talk about saving cost, if you have an IoT solution, definitely we look forward to it. But at the same time, we want our privacy to be preserved, right? So privacy preservation is definitely is a focus when we enjoy such benefits by IoT based solutions, right? So one good example of privacy in the smart home setting, or especially when you see devices such as smart TV, right? So when you watch a TV, um, I mean, when you agree to share your details, when you watch your smart TV, you watch some channel, so your viewing pattern data is automatically shared. Similarly, when I wear my wearable device for fitness purpose, right? So definitely, wearable device is also a part of this connected world. So I share my information, right? Fitness information. So there are multiple such examples. Healthcare is another one, right? Now, when we see that we have devices such as wearable devices or devices in the smart home setting, right? Or there could be wearable devices for old age people living in the ambient, um, assisted living. So this is another good example of how the devices in the ambient assisted living can, when provide some information or can share some information relevant to the activities of that old age person, the movement of old age person, that may um, pose some privacy related challenges, right? So who is doing what is something which we define as privacy, and that needs to be taken care of, especially when we enjoy such IoT based solutions. So device security is mainly related to the security aspect of the embedded devices, and I think when we see these IoT devices in the form of microcontroller boards or embedded devices having limited battery and limited processing, right, powered by battery. So I mean, we need to take care of this device level security, ensuring that um, I mean, you have the remote firmware updates for security for such constrained devices is like a big challenge. So when we say that I have got my uh, RPi device, right, as a gateway, RPi 3. So getting any firmware update for RPi 3, especially like when you have this constrained environment, right, it becomes a big challenge, right? So trust is actually is quite inherent in internet. As I said, now when we talk about internet of things, right, for this internet connecting billions of devices, um, so you can easily understand that in the IoT setting you have multiple sensor nodes connected to a gateway node, right? And then from gateway node you can then send data further to the cloud, right? Or you may do some kind of edge processing on the gateway as well. So in IoT, we use gateway as an intermediate device, right, between sensor and cloud to offload processing. So some part of processing can be done on gateway, as I said, I think in my previous session. So this is called edge computing, or doing some processing on the gateway device for some latency sensitive applications, right? So which means that the gateway device may have, some, I mean, gateway devices actually is quite vulnerable here, right? So this gateway device can also be used as an aggregator node for applications such as smart grid, right? For other smart utility applications such as smart water metering applications, right? So definitely gateway creates a new attack surface for attackers. So which means that if gateway along with sensor nodes, they both are a part of this huge internet of things. So the trust model which we talked about for an internet breaks down when the security of any of these intermediate nodes is compromised, right? So there are multiple solutions now. One uh, emerging solution which you people must have heard of is blockchain solutions. So these solutions are very promising these days for addressing to this trust. right? So now, after discussing these 5 important IoT security related challenges, now I would cover basically a case study on security and privacy challenges in smart grid. So this is based on our own work in the last 5 to 6 years, right? So when we picked up this problem and I gave it to my PhD scholar, I hope she must be attending this session. So Pratibha, who completed her PhD on this, I would like to cover this case study, and this is one good PhD work, and I think this may motivate some of you to take it forward and do it for some other applications, doing advances in the proposed work, right? So yeah, if somebody is keen to associate, the person can associate with me as well as Pratibha, who is working in Sinhegad College, Pune. So yes, this gives you an overview or the big picture of how smart grid looks like. So in terms of uh, networks, right, you can see that the right hand side, if we start with this right hand side, so you have this home area network, right, where you have the smart home setting, providing the data through the smart meter, right? And there are multiple such smart meters, right? So when you have an apartment, say a 24-storied apartment where each floor has got 5 flats, so that means that building has 100 such flats, 125 flats, sorry, and then you have 125 smart meters providing data from that particular area, right? So, or you can have many such um, uh, high-rise buildings providing lots of smart metering data, one smart meter for each home, right? So you can have then the home area network, then you have this neighborhood area network, which is basically based on many such meters in the neighborhood, right? So if you have got some you can say some what do you call, within 100, say within 500-meter area, right? So you can have multiple such high-rise buildings, and that may form some neighborhood area network. Then you have your wide area network, okay, and then finally you have your control center collecting this information. Okay, so this basically defines your complete smart grid network, and you may have a similar kind of network for water, right? So this is the electricity network, right? So you can see here you have all these customers' premises as well as you have electric vehicles, right? Uh, Providing data to the microgrid in the neighborhood area network. So you may have microgrids, right? Collecting data from, collecting basically, you can say if you have the customers having electricity generated on their premise by having solar panels, so the energy can be then stored here in the microgrid, right? Then from the microgrid, you can have the energy to the substation, right? So that's how basically you can have a typical smart grid network. So you might be wondering that where is the privacy here, right? So you can see here, uh, now if you see that privacy concerns in the smart grid here is based on, um, so here you can see that the privacy itself is defined under 4 broad categories, right? It could be based on personal information that forms a part of privacy, right? Or that could be based on some behavioral kind of privacy, right? So for example, I have my personal behavioral pattern information which I am sharing through my wearable device, right? Activities, for instance, right? So that comes under the behavioral kind of privacy issue, right? Or you can have your personal information such as like customer's identity, right? So that is based on like customers ID, financial information, energy related data, right? That is your personal information. And usage information, that is also kind of personal privacy, right? So that's how, I mean, you can have the division of personal privacy in the form of personal information, personal privacy, behavioral privacy, or personal communication privacy. Okay. Now, specifically, when we see the privacy preservation schemes in the smart grid network, I mean, some of these schemes we have covered here. Um, Yeah, so some of these schemes you can see here are broadly classified as homomorphic encryption schemes, elliptic curve encryption schemes, and lattice-based schemes, right? So these schemes are based on how encryption technique can be used for privacy preservation, right? And some of these schemes are quite popular in the past, but there is some advances now in terms of lattice-based cryptography, which we try to capture in this. So elliptic curve cryptography is actually considered as the lightweight cryptography because of the operations we use, right? So we use basically linear operations, right? So that's why elliptic curve cryptography is considered as lightweight cryptography because of the mathematical operations we use for developing that public key cryptography system, right? So the attacker is mainly interested to obtain the key in this public key cryptography, right? Which is not that easy. But if you have those powerful machines, especially quantum machines, okay, now when you talk about a powerful machine or a machine which can actually perform a simultaneous attack and can do large amount of computation to get the key, that is, I think, perhaps the main challenge, which is a focus of this particular work. And so most of these security solutions which I am discussing here, providing privacy preservation, right? So encryption based privacy preservation, right? So most of these schemes under the public key cryptography, they are either based on this integer factorization problem. So these are the two fundamental problems you might have studied, right? So the crypto systems making use of this public key cryptography, especially, let's say RSA failure crypto system, right? Homomorphic based crypto system, Elgamal's crypto system, or elliptic curve cryptography, right? So these algorithms are based on either integer factorization or discrete logarithm problems. So due to limitation of time, I'm unable to cover these mathematical problems in detail. But one thing which I can say here, that these problems, I mean, the algorithms based on integer factorization or discrete logarithm problems can be cracked by using quantum machines. So, of course, I'm talking about quantum computers, which is a distant future. I don't know how far. But based on some evidences in the past few years, one thing is a bit scary, that very soon, maybe like 5 years down the line, you may find there are more quantum computers in public spaces, right? So it would be then a challenge of how to secure such platforms when you have such powerful machines. So this particular study is actually focused on, a near distant future, uh, when you have such quantum machines capable of doing large amount of computation to get this um, key, right? Secret key for this public key cryptography, right? So these two algorithms, if somebody is interested, you can read about Shor's algorithm or modified Shor's algorithm, and both these algorithms have shown an evidence of how these crypto systems based on integer factorization or elliptic curve discrete logarithm problem can be solved by using Shor's and modified Shor's algorithm. So the important question here is, now everyone can ask this question, which I am asking here: how to secure IoT systems for these future attacks possible by quantum machines? So one possible answer is lattice cryptography. Now, of course, what is this lattice now? So if we compare broadly this lattice cryptography with the standard cryptography based solutions, right? So we have seen that standard cryptography is definitely based on integer factorization or discrete logarithm problems. And as we have seen that these problems can be solved, which means an attacker can obtain the key. That's the whole objective of an attacker, right? So attacker is always interested to get the key so that attacker can either read the message, can modify the message, right? So whenever you have your data or your information, and if you apply this public key cryptography to secure that information, definitely you make the use of that secure key, and you try to make that key strong by using it as 1024-bit key, or you make it even more secure by using 2048-bit key. But the thing is, when you make it complex by using more number of bits, right, to make attackers life difficult, definitely it requires more, you can say, computation, right? So definitely such solutions may not be applicable for IoT based applications. Reason: we have seen that IoT applications are basically making use of constant devices, having very limited memory, limited processing. So definitely, even if you use a solution, a secure solution, that should also be lightweight, right? So lattice cryptography is based on using lattice, right? So lattice is basically a combination of vectors, right? Linear combination of vectors. So lattice has got, again, I'm unable to cover this lattice cryptography or to talk more on lattice, but all I will talk is how we have used this lattice for smart grid application as a case study, and what was the outcome of this work. You can actually see in terms of both security as well as the performance, right? So lattice based cryptography is based on solving a problem which is called as shortest vector problem. It is very hard, right? So that is based on hardness of lattice problems, and as I said, shortest vector problem. Those who are interested to know more about lattice and the shortest vector problem, please read about it. Okay, so this makes the life of attacker quite difficult, and even in the presence of quantum machines. That is the whole objective of this particular case study on privacy and security using lightweight lattice cryptography based solution. Another important thing is lattice cryptography do not use these modular exponentiations which we normally use in RSA. So those who are acquainted to this public key cryptography solutions, right? You must have seen how we make use of modular exponentiation, right? When we write the LGML algorithm or RSA algorithm, right? When you apply these algorithms, and even if you try to make key with a large number of bits or key with a bigger size, definitely it makes the complexity even more. The reason, you use modular exponentiation, right? So this lattice cryptography can achieve the same level of security with very simple computations. It does not involve any modular exponentiation. So that's why it comes under this category called lightweight cryptography. Of course, lightweight, as I said, ECC was, ECC is still, is a good candidate for many applications, such as like securing data on mobile phones. I think there are many solutions based on ECC, right? So if you look at the data security for many mobility based solutions, you will find that multiple research groups have actually made use of ECC based solutions. Similarly, wireless sensor network, another area where people have made use of ECC based solutions, right, for securing various applications, making use of wireless sensor network, right? So this lattice cryptography has got some, you can say, encryption based on ring learning with error or using NTRU, right? So our focus was more based on ring learning with error technique, and we applied this technique because there was no prior work on using this particular technique for preserving privacy for such smart grid IoT application, right? So all we did is we performed, security analysis, and we also did a performance analysis with other schemes, right? So this is how you have the smart grid, you have the individuals, you have the retailers, right? You have this third party, right? And this PCC is, so this particular scenario is actually for a prosumer, where prosumer is actually considered as not only just a consumer, but he is producing electricity as well. That's why it is called prosumer, right? So this work was done in association with a researcher from Curtin University, Australia, and he had lots of experience on this prosumer based smart grid data analytics, right? So this smart grid, practical smart grid, is actually is a kind of a grid in which you have not just consumers, you have prosumers having these solar panels on their smart home, right? So you can see here that we have got the PCG, that is what you call this prosumer community group 1, group 2, group 3. So you can have a kind of clusters of such prosumers, right? And they are connected to this what we call prosumer community coordinator, right? And this is your trusted authority, right? And you can see here all these stakeholders, individuals, retailers, and you have utility grid. Okay, so yeah, you have the communication using your wireless um, wireless communication, right? So you have got that wireless communication sending information from each prosumer to this CG, right, which is community gateway, kind of aggregator node, right? So the protocol which we proposed here is a lightweight protocol based on lattice cryptography, right, for this prosumer based smart grid, right? So you can see here that the prosumer community coordinator. So here, prosumer community coordinator first broadcasts the public key, right, for encryption and signature to the community gateway. If you see here in the previous slide, right. So it's first the communication from the PCC to this uh, community gateway, right? And then the community gateway broadcasts these public keys to the prosumers, right? And then you can see that this community gateway has got this what you call computes the supply forecast values and the expected price, and it's then sends the encrypted supply forecast and expected price with signature, right? So in the smart grid setting, I think it's basically more of how you manage the demand and supply. So which is like the core problem, and definitely you have to manage uh, with the demand, like how you can, um, I mean how you can. So this is like that traditional capacity planning problem in the networking. Now the same capacity planning problem in the networking can be seen here as how you can plan for your storage or for your electricity supply when you have a demand, and when the demand increases. Now we have seen, because of the urban sprawl or for increase in the urban settings, right? So we have seen this, right? So 60% of the, that's why like there is a growing emphasis on smart cities, right? So most of the population is now living in these smart cities or bigger cities, right? So having a clear estimate of demand is quite important. So demand side management is like a very fundamental problem in the smart grid, and these terms you are seeing here is based on that. Now, once you have this, the key which you have seen in the previous, this like public key for encryption and signature, then this presumer uses that, and if supply changes, presumer then communicates that to the community grid, and then community grid, communicates this if price changes, right, and finds a new value, and then broadcast this new with a signature to presumer community coordinator, right? So it then broadcasts to both presumer as well as the community grid, um, right? And then if the goal changes, of course the community grid then update the goal, and then presumer community grid, that is coordinator PCC, then generates the monthly bill amount, right? So which means that if you have anything changes on the presumer side, for instance, presumer is generating electricity, right? So if there is any change in that side, definitely the PCC takes care of it and then provides some benefits in the monthly bill, right? So of course, if I am a presumer generating my electricity, definitely I am going to get a benefit in my next bill, because I'm providing some. I mean, I'm having my own electricity generation. So government is actually promoting now individual households to have their own electricity in addition to what they receive from the traditional utility grid, right? So of course, this is what I wanted to show you as a background, which is of course uh, proposed as a protocol. So this paper is available. Those who are interested to read this paper is there. Proposed by. I mean, this paper was actually published last year only. So you can see this paper. So she is my PhD scholar. She has completed, and this paper was published in Helion Elsevier in 2019, right? So you can check this. So our protocol is definitely is based on using two parameters, and we accordingly have two variants of this protocol using these two parameters, p1 and p2, and then each has got n, q, and the sigma as three different parameters defining p1 and p2, right? So p1 and p2 defining two levels of security, medium and high level security, right? And we compared then our scheme with three more schemes, RSA 512-bit scheme. Then there is another scheme, Algorithmic encryption based scheme, and then there is one more elliptic curve based scheme, right? So these three schemes we compared with our lattice based cryptography, and then we worked on two different scenarios, right, in which we have one PCC, one CG, which contains number of presumers from 10 to 100, and in another scenario we have used one PCC and number of CGs varies from 1 to 10, where each PCG has 10 presumers. So under these two different scenarios, then we compared our performance evaluation of our proposed scheme. So you can see that LRSPP is our proposed scheme, that is lattice based scheme for presumer side network, right? And we compare it with three different other schemes, and then you can see here that uh, the performance is improved quite significantly in the schemes such as elliptic curve based scheme. If you see the blue one, or this is the algorithm based scheme, right, the red one, the performance increases when you increase the number of presumers. So you can see on increasing the number of smart meters, the number of messages per month increases quite significantly, right? Whereas in our case, the number of messages, even though we have more presumers, we have this line quite flat, right? So number of course, like if you see on the y-axis, the number of messages, if you see here, is quite small. It will show you uh, the quantified side as well. Similarly, here in the other scenario also, the results are quite similar, right? So our performance improvement here in terms of number of messages per month by increasing number of presumers. So we have least number of messages. So message overhead or communication overhead is very small. So another, you can see performance evaluation in terms of computation overhead again is quite small, right? So you can see the computation time in seconds with number of presumers when increases from 10 to 110 is quite small, right? And this, when we compare it with the other schemes, you can see that the computation overhead in our case, since it is very small in terms of number of seconds, you will see it is almost touching to this x-axis, right? Because in the previous in this slide you can see that it is in the order of less than 10 seconds. So whereas in other schemes the computation overhead is quite large, right, in thousands of seconds. So I think the solution which we proposed is intended for privacy preservation for smart grid network using encryption scheme, and definitely the scheme which we used is an advances to this cryptography, right? So if you read about lattice cryptography, you will see that there is a growing interest in this lattice cryptography um, for IoT applications, right? So we applied it for a smart electricity grid, but you can see that a similar solution can be applied with advances for other utility networks as well, right? So if you look at this highly distributed smart grid network, more specifically in terms of the transactive nature, because here you have a prosumer, not only now just acting as a consumer of electricity, now the prosumer is producing electricity as well, right? Now when each now when we consider a case, or in a distant future, when we see that each household is generating its own electricity under a complete smart grid setting, so you will have a completely new transactive energy management system, right? So in that case, we would require basically an appropriate solution that could be maybe like based on um, that should match to this transactive kind of energy system. So possibly, blockchain could be one solution that people can adopt here to address to such new transactive energy systems. Few more use cases one can see here. Smart home, as I said, right? So you have number of smart appliances in a smart home setting, starting from smart TV to smart refrigerator, and now people are having more smart devices in smart home, right? So when you so smart refrigerator, you have smart kitchen. Now people are going to use so smart refrigerator. You have other smart devices, and so people are now focusing more on smart kitchen, right? So you can see with a growing interest on making kitchen as smart. Similarly, you have most of other devices also. You have your air conditioner, of course, right? So in a smart home setting, you have 5 to 10 such smart devices, and through each device you are sharing some kind of information, right? So of course privacy is one big challenge, as I indicated before. That's why like privacy is quite widely discussed, and in an umbrella term you will see it as a privacy preserving analytics, right? Those who are keen to work on this, so privacy preserving analytics for IoT platforms is basically the umbrella term, and then you can focus on some solution technique, right? So you need to understand basically the problem very clearly, and then you can pick your solution accordingly once you understand the limitations of other solutions, right? So what we have discussed as a case study for smart grid doesn't mean that it is like a complete solution for all types of IoT applications. Definitely, you have many more possible solutions. ECC, as I said before, is still considered as like the most simple and you can say um, widely adopted solution so far, right? So if we don't consider the fear of that quantum machines, ECC is still like one of the potential candidates even for IoT devices, right? So the case study which we proposed is definitely is based on looking at some futuristic quantum machines and the attacks if it happens through these machines. So this slide just provides you the ranking of various privacy issues in the smart home setting, starting with the identity theft to um, the spyware kind of infection, right? To the hacker gaining access of device, which is quite popular in this smart home setting, as I said, right? Your private information made being public, right? So you can see that. So privacy is one of those top 3 to 4 challenges in the smart home setting, other than the problems which you see in this category as privacy issues in a smart home, right? Okay, so well, I think this is another important area where most of these researchers are very worried about security for connected cars, right? So some of these interesting videos or some of these interesting use cases you must have seen, right? So yes, when we talk about autonomous cars, one thing is very clear, that if somebody hacks any particular car or any particular autonomous vehicle, it's quite challenging, right? So security issues for connected car is definitely is an ongoing and active research problem, which a research community can definitely focus on, right? Healthcare, I think healthcare privacy related challenges or the solutions addressing to privacy in healthcare has been widely discussed. Most of these solutions I have not covered, and I'm not going to cover it as well. But you can read about the privacy challenges for the healthcare, being addressed using differential uh, privacy, right? Uh, Using encryption-based privacies, um, yeah, anonymity-based techniques. So there are many solution techniques being proposed and developed for healthcare systems, right? So this area has actually seen a lot of work in last 8 to 10 years, right? So that's it. I think this is what I wanted to cover in this session on security and privacy issues for IoT applications. So thank you so much for watching me on YouTube live. And if you have any question, I think we keep this session open for 5 to 10 minutes for questions. Okay.
Thank you very much, sir, for this very good informative session, sir. And thank you very much for including one of the case study from your PhD student. And
Okay.
sir, here we have questions from the participants. So
Okay.
very first question, are there any lattice cryptography APIs available in the market so that we can develop secured IoT applications?
I think this is uh, there's an echo actually.
Okay. Are
There's
there
an
any
echo.
are there any
Yeah.
lattice
Yeah. I can hear you. Yes.
okay, so
So
are there yes sir.
yeah. So I think I would suggest you to, yeah. There is an echo actually. Can you just mute your mic, please?
Yes sir, yes sir, yes sir.
Yeah. Can you hear me now? Okay.
Yes, sir. Yes,
So
sir. Go on.
yeah. So the answer to this question is definitely this is a good question. I mean, according to my understanding on this lattice cryptography, uh, there are solutions available, based on NTRU, as I said. So there is a group active on NTRU. So I would suggest you to look at this group from the University of Waterloo, Dr. Shen, right? Dr. Shen. So you look at the work of Dr. Shen on NTRU, as well as you can have a look to our paper, right? And then definitely you can work on this. Now, in terms of having any lattice based API available, I'm not sure. I think you have to check, because when we were working on this, uh, uh, I think you checked NTRU encrypt is there. I think you check that NTRU encrypt. Okay. Yeah.
Okay, so another question is there, sir. Which are the quality of service parameters that can be considered for security enhancement in IoT and industrial IoT?
Um, Quality of service parameters for security.
Security enhancement.
Okay. Uh, See, when you talk about the quality of service quality of service is mainly relevant to the network performance, right? So, I mean, I understand that quality of service here you are referring to the network performance in terms of the network bandwidth usage as well as the network latency, right? So I'm not getting this question very clearly because this question is mainly related to the network performance specifically in terms of the network bandwidth or the maximum link utilization or the delay or the throughput.
Okay, sir. So I'll take another question. Should governments have their own clouds rather than international clouds?
Should government?
Should government have their own clouds rather than using international clouds?
Uh, this question I think is mainly related to I mean how the government can have so this is more related to policy basically, right? So what I believe is this is more this question is more relevant to government owning cloud and enforcing policy actually. So in a way I think this question is important in terms of government having their own cloud with their own policy enforcement. So I think of course it should be, but I think in ideal setting, yes, it should be, but practically I think I don't know how far we are from this.
Okay, sir. One more last question is there. Why only lattice cryptography is used for security solutions? Is there any other method can be used?
Yep. So as I think as I emphasized not twice, thrice, that lattice cryptography we chose looking to some futuristic attacks by quantum machines, uh, particularly having this challenge of distributed denial of service attack. So distributed denial of service attack is one big challenge for internet or any internet based application. So IoT is one such huge network. Now when IoT is connecting such billions of devices, now imagine if in near future, let's say 5 years down the line, if we have commercial quantum computers available in the market, we definitely require a security solution which can then provide a security against such attacks being done by quantum machines. So lattice is one possible solution under this lattice cryptography, which is making use of combinations of vectors, linear combinations of vectors. So getting a key is just like solving a shortest vector problem, which is quite hard, right? So there is one more solution technique under lattices. NTRU, as I said, is developed by University of Waterloo team, right? So they developed that scheme even before we developed it for this smart grid. In addition to this, you have other techniques like elliptic curve, ECC, right? So ECC is one very good candidate for lightweight cryptography, right? So ECC also uses simple mathematical operations while you develop this algorithm, right? Elliptic curve. So point multiplication, point doubling, those who are acquainted to ECC, right? Compared to modular exponentiation, which is quite complex when you run this algorithm on these small devices, embedded devices, right? So ECC is one another possible technique as a lightweight encryption solution. Homomorphic is another one, right? So of course there are multiple techniques. I think I started with that. So homomorphic, ECC, and of course those who are interested to explore more, on encryption-based privacy preservation for IoT systems, you can definitely have a look to lattice cryptography. Thank you so much.
Okay, sir. So can we take another question? A last question is there from the audience.
Okay. Yeah.
Shall we apply lattice cryptography for smart water quality monitoring application?
So yeah, I think as I said, see, I presented it for smart electricity grid. Definitely, one can apply for other utility applications. So smart water is another utility application, right? So which is quite similar to what we presented for smart grid. So it's quite similar, right? So all you need to do is to just, I mean, try and consider your use case in terms of the number of devices, right? So yes, answer is yes.
Okay, sir. Thank you very much, sir.
Sarita madam, 1 second.
Yes,
Behalf
sir.
of sir MMCOE, actually I would like to thanks Dr. Agrawal sir for having such a nice sessions. So 3 sessions he has covered a lot of practical and research approaches of IoT, networking, IoT cloud and IoT security. So I personally, on behalf of MSCOE Computer Engineering Department, I thank sir for taking so much efforts and time for us, for our participants. So I hope participants has really been empowered and enriched with your knowledge and your experiences. And they will definitely will utilize and will start towards their research goal. Thank you very much, sir.
Thank you so much for taking all your efforts to invite me and giving me this opportunity to talk with your faculty members and other faculty members. Thank you so much, Dr. Sandeep. And yeah, I thank Sarita and other team, right? Thank you so
Yes.
much.
Yeah. Thank you, sir.
Thank you, sir. Thank you.
Okay.
Now I request Dr. S.M.Chaware, sir. He'll be conducting our next session. So we'll be starting our next session soon. Okay. So I would like to give some information to related to the Chaware sir, what he done and all these things. So Dr. Sandeep Chaware sir is working as a professor in MMCOE College of Engineering. He is having a very vast experience in the teaching field, 23 plus years of experience, and he is having 11 years plus experience in the research. His research research area of the interest, wireless network, information security, information IoT, mobile-based technology. Now I request Chaware sir to take over the session.
Yes. Hello everyone. Very good afternoon and welcome to this session. So I understood and hope that's what are the sessions we kept. What are the sessions related to IoT advancements in IoT, networking, sensors, and other things. The experts had given the practical and you can say research aspect uh, throughout the session, right? So my session will be something different. It is related to research areas and opportunities in IoT, considering you can say a vast growth of IoT network in future. So this will definitely will help to all the participants to some extent. And if you have any query, you can post on chat box. So first of all, I will like to thank all participants to be a part of this FDP, and you might have attended all the sessions. As far as the contents of this FDP are concerned, thanks to all experts also being with us, and my entire team who is taking a lot of efforts for streaming these videos and the live sessions for you on YouTube channel, right? So just I will share my screen. Is it visible, Sarita madam? Okay.
Sir, it is visible. You can continue, sir. Thank you.
So, Sarita madam is visible and I'm audible?
Yes, sir. Your screen is visible and we can hear you, sir.
Okay. So let me start my session. My session is related to research challenges and opportunities in IoT area. Uh, Basically, we had a lot of, you can say, thought process in IoT or IoT platforms and other areas related to that. So just I will focus on what are the different research challenges we may take up and what are the different opportunities through those particular challenges to go ahead in the IoT area. So as far as today's session is concerned, I will be focusing on these 4 or 5 points: IoT perspective, enabling technologies and developments in IoT, applications of IoT, research challenges with applications in IoT. That is what the major focus of this speech, and what are the different opportunities in IoT. So this slide gives you a very basics and you can say a thought process about the IoT. So IoT works with the help of internet, right? So IoT connects whatsoever the objects we have in and around to form a network, and that particular network should be connected to the internet in order to govern various services to and from the object, right? So we are looking out the objects in such a fashion that those objects may not have enough computational capability, enough intelligence, enough enough I can say capability for interconnection or connection to the other device, and so on. So we are identifying those, you can say, physical objects out of the environment, and we are making those objects in a such a fashion, or transforming those objects in a such a fashion they will be able to or capable in the sense interconnect to the other objects. As far as connection is concerned, they are able to send the data, whatever the data they have in and around, and that particular data can be easily processed, and based on that analysis of the data, other objects will start behaving. So such a kind of environment, let's say down the line, let's say before 10 years, 15 years, nobody was thought about that. So at actually physical objects only, they are lying with us in and around. How that makes sense to identify the environment, to have some certain data from the environment, and that the data should be utilized and will be make some sort of sense through the internet, right? So internet has governed a lot of things to us, so that these particular objects uh, through some let's say techniques and technology will be able to interconnect together. So as far as IoT perspective is concerned, I can make 3 dimension of understanding the IoT. On the x-axis, I can have IoT maybe in the form of any place where IoT network I can have either indoor, I can have that particular network as an outdoor, or I can have that particular network on the move. So there are no constraints as far as your environment or place is concerned, right? So at any place, anywhere, so that particular environment is available to us. On the y-axis, we have at any time. So time constraint is not there. So 24/7 at any moment, anything that is available with the object, with the data, with the processing capabilities, with the internet and other things, so that those objects will be a part of computational intelligence, right? On the Z axis, other axis, we can have anything. Now, anything is very, very important to us as far as IoT is concerned. Now, anything may be related to the objects, the, the anything that is also been related to the human and thing or thing to thing. So these two concepts are very important as far as IoT perspective is concerned. So what we have the three or five A's and three I's in our IoT language, IoT domain. So those should be fulfilled with respect to these particular perspectives. So this slide gives you a little focus on life cycle of an IoT, which is consisting of majorly four, you can say, phases. One is collection, another is communication, third one is analyze, and fourth one is action. You might be familiar with this. I will not spend more details about this, but the collection is concerned. So these are related to only a data. So now the data is very, very important as far as IoT network is concerned. How that particular data can be easily acquired from various devices and through various means with a set of technology and tools that are very important. So that particular data may be available at home, may be available inside a car, or may be available at the office, or maybe in the manufacturing plant. So data is everywhere. So how that particular data will make sense as far as collection is concerned. If I found some collection methodology, then I can proceed further to make that particular data for communication. Now, as far as communication is concerned of that particular data, we have various devices that make some sort of sense of making that particular data that received from the sensor in such a fashion that that data should be easily been communicated over the network. So we have various networking protocols. We have various network, you can say, architecture, various network standards, which defines the methodology in order to make data easily communicated among the devices. So that data will make some sort of sense. Should be available on the cloud platform, or should be available at the data center, or maybe let's say home network and so on, where something that can be done with that particular data. So this communication is very important because communication has a many threats, many, you can say, in and around security aspect. As far as IoT is concerned, it's a wireless network. So the threats and privacy issues are many more. So we need to find a correct way for communication. Then the third phase for this life cycle is analysis. So creating some information out of the data is analysis. Once I have this particular data has been communicated and received from the various devices, I will be able to analyze that particular data in the form so that information has been received. So that information will make us or a device or an object to prepare for further action, for further, let's say, processing part. So analysis can be done through various analysis methodologies, what we have on making that particular big data analytics and so on, analysis methodologies. So that particular data can be easily useful for representation in the form of a visualization of the data, or we can prepare some reports from the data once analyze the particular data, or you can have some sort of filtering data so that that will be easily been available for further action. And the finally is the action. So you can say it is a, you can say action is based on the information and data that has been received among the objects, right? So it is totally depends on data collection methodology, communication methodology, and analysis of data. Once that all these three aspects has been fulfilled to some extent up to the level, then that particular action can be easily been decided. Now that action can be decided by a particular object, or by a particular platform, or by a particular machine, or anywhere, right? So action, it depends on the application. Action, it depends on the environment, how that action will should be initiated. So this life cycle is very, very important as far as IoT network is concerned, which will be concentrating on putting those particular IoT components into an integrated IoT network, so that we'll right from the collection to the action, all number of these phases should be you can say tackled. This also that you might be familiar with this, but I'll just have a overview of this collection and communication of these phases, how it has been related to the IoT working of IoT. So we have, let's say, various data that can be easily been tracked through RFID tags, or let's say data can be collected from the sensors. It's a collection methodology. And we have the communication methodologies in terms of integrating those particular sensors into the network with various communication protocols and networking environment, so that it is easily been available to the other devices for further processing and so on, right? So we should have a various nanotechnology that have been available now with the very, very small things that has been coming up as far as data processing is concerned, that will really be you can say used in order to provide certain you can say a platform for further action by the device. This also you may have a familiar with that model of IoT in terms of 4 layers. On the downside, we have the sensing and identification layer. Yes, we have various devices like GPS, smart devices, smartphones, RFID device with sensors and so on. So which has a capability of sensing the data from the environment, and which can be easily been identified in that particular environment with identification methodology. Now these ones that devices are there, so that should form a network, so that they will be able to interconnect together and make some sort of sense of that particular data what has been sensed from the environment. So there is a network construction phase. So network construction may be in the form of an internet directly, maybe in the form of their own WPAN, let's say WWAN, or let's say maybe WLAN and so on. So number of network options that are might be available, so that those particular devices may be the part of that particular network in order to have the interface between let's say IoT network and the external network. So once it formed the network, so that is what the capability of the network is in terms of communication of data and information, uh, maybe for the further processing. So further processing step will be required for that as a third layer. We'll have information processing for that. We may have various data centers, various information security centers, may adapt various data mining techniques, search engine techniques, smart decisions, and so on. So based on the application and you can say data, you may go for either of the processing of that particular information. Once that information has been processed, that can be easily been utilized for various application area. For example, it is a smart logistic, or let's say a smart grid, or a smart transport, or let's say a smart building, smart city, and so on. So that is what we need, some kind of integrated application where such kind of information as a process data has been easily been received from various objects of IoT network and other network connected together, so that will form an integrated application in order to solve or in order to govern such a kind of IoT services through that particular application. So definitely we'll be needing looking out these 4 layers as a IoT network. Let's talk about enabling technologies of IoT. Yes, we are really hearing from so many number of months and years that this industry 4.0 evaluation has been started. So that a number of industry that have been coming up with the automated and let's say embedded solution for various processes among the industry and outside the industry for various application areas. So what we are looking out. So industry 4.0 should be targeted with related to the quality control, related to the asset utilization, workplace safety, product monitoring, supply chain management, and so on. So here only the 5 points has been given, but we have the many more points is related to the industry application and industry type and category. So that these 5 points will look at the various aspect of industry automation and so on. So we have asset utilization. So whatever the asset we the industry has, they should have an asset uh, asset performance module, so that they will directly will target to that particular asset as far as performance is concerned. So they will have various, you can say, things related to the performance in terms of, let's say, failure rate, in terms of availability, in terms of, you can say, success rate, in terms of downtime, in terms of recovery, and so on. So they will just monitor the various assets and their utilization, so that the productivity should normally will increase, right? Workplace safety is also very, very important aspect. So it's possible through IoT technology that the safety and, you can say, environment that should be at place to, as far as industry is concerned, to all the workers, to all the employees, so that they will feel something as a safe, uh, towards identifying the, you can say, various hazardous conditions of assets, or you can say various, let's say, unpredictable conditions, or other environment, you can say, conditions. It depends on the industry. So with respect to this, whether IoT itself will prepare that, okay, with these conditions, how to tackle as far as safety is concerned, right? Similarly, for quality control, they have this quality parameters, and quality parameters can be easily been tested, and the performance based on the quality parameters can be done using the IoT itself directly. So the evolution of Industry 4.0 will have the drastically uses of IoT enabling technologies to adapt these technologies for improving naturally their businesses and production quality. As far as Industry 4.0 is concerned, you will see that number of, you can see, industries and, you can say, other corporate vendors that has been came forward, and they have been working since so many years to give these particular enabling technologies for the IoT. So uh, as far as technologies are concerned, we should have a smart module like SIM card, sensors, embedded chips, and so on. We should have a smart objects like vending machines, appliances, meters, and so on. We should have a connectivity. We should have a smart platforms for processing of IoT data. We should have a software customization as far as interfaces and other things are concerned. We should have various applications related to the IoT area, to the industry, and we can identify the various customers in order to buy those particular services through these particular, you can say, number of layers that has been identified to go ahead with the IoT solutions, right? So we can see that the number of companies that have been coming up, like Intel, Samsung, then you can say Vodafone, AT&T, Cisco, Microsoft, Infosys, Accenture, SCL. So many number of MNCs that have been coming up uh, forward to work on these various phases. So that will be really, I can say, their contribution towards making this particular environment as an IoT enabled environment of Industry 4.0. So we have IoT developments. I have a little, let's say, focus on this. The development from, let's say, January 2019 to 2020. So development that has been related to the, you can say, an acquisition and investment of IoT area. Then some research findings as far as various companies are concerned, or their major announcement, right from, let's say, January 19 to 20. So you can see from this slide, Amazon, let's say, Microsoft, Samsara, VMware, Siemens, Lime, all these companies are related to the various aspects of using utilization of IoT enabled technologies in order to solve their business problems or processes. So already we know the Amazon is there. They are already been using IoT with along with the AI techniques to have such a kind of, you can say, business processes. Microsoft also, they are having these, I know, IoT signals. VMware. So these are the major MNCs. They have been coming up forward to have various, you can say, announcements and, you can say, interest towards, uh, you can say, research and utilization of various IoT enabling technologies. This slide give you a little focus on industry 4.0 market opportunities. Let's say for a decade, 2020 and 2030. So we'll have see this number of you can see investment from various MNCs. Let's say Morgan Stanley with 2015 we have $19 million to 110 billion by 2020. So IoT market has been improved from 110 billion to 123 billion in 2021. Now they may have think, let's say, due to Corona and these particular conditions. But as far as let's say development of IoT is concerned, utilization of IoT services and you can say efficiency of IoT enabled technologies are concerned. So naturally, the IoT market is booming, has been growing a lot, and by 2023, we will see that a number of countries, top countries like United States. With an investment of 7.3 trillion, then China, then Germany, United Kingdom, and so on. So number of countries they will coming up with various investment policies and investment techniques in the IoT as a enabled industrial IoT uh, in industry 4.0. We have various IoT trends for 2020, like it's already been initiated smart cities in developed countries. See the smart cities, we are looking out the city, the services and the people with as a smart, those who have been should use this smart the services from the environment very smartly. As far as blockchain is concerned, is also a part of this particular IoT. Has enabled this IoT data to be a securely been, you can say, transformed from one process to the other process, or from one industry to the other industry. As far as blockchain is concerned, right? So he'll be hand in hand. Blockchain and IoT, they have been utilizing their you can say features to make the data as far as security is concerned. So with respect to this, let's say the investment might have been increased by 2023 with 174 to 573. Sensors innovation also, there are a lot of sensors that has been coming up to sense various kinds of data, and they have their data formats and so on with from the environment. So we are now sticking to the very specified environment, but the environment may be a dynamic one. So we need some kind of innovation in sensors. So that is also been one of the top IoT trend. Yeah, utilization of AI, as I said earlier, the Amazon and other companies they already been coming up with the AI and IoT together to have a certain you can say applications uh, as far as their business service is concerned. So this gives a very brief idea about the applications in a broader way. We have already know the applications of IoT or the smart grid or health, home, then industries, cities, and so on. We will be looking out the more evaluation of the IoT industry towards these you can say uh, enhancement of IoT towards in these particular IoT applications. It's already been covered. Again, media, environmental monitoring, infrastructure management, energy management, transportation, and so on. So not a single, you can say, sector, or you can say an aspect that may left out as far as IoT is concerned. Yes, I will give a brief idea about the applications of IoT supported as a sensing as a service from a cloud platform. You might be familiar with this. You have a garbage collection or a waste management system as far as in smart city is concerned. Now we may have let's say garbage bins that may be lying at one corner, and these particular have some kind of IoT enabled sensors which sense the garbage as far as their labels are concerned or type and category of garbage is concerned. It may be now been connected to the another device wirelessly through that particular platform to the cloud platform, right? So there might be various types of categories of garbage cans or a garbage truck. They may have a let's say various types of sensors in terms of sensing the garbage and garbage cans, so that those particular information should be available on the cloud platform as a sensing as a service. Now cloud platform will now be in a position to uh, sense these particular data, and he will make that particular data as a service to the various you can say platforms in and around, maybe to the manufacturing plant, maybe recycling plant, maybe health and safety authority, and so on. So by looking at this particular you can say cloud platform, the data from the sensors and with related to the data, the services has been governed by the various you can say agencies. So agencies will get benefited out of this particular cloud platform once this particular data and information has been easily received from the IoT enabled components. So it is a, I think you can say it is a smart city approach for waste management. Another application I wanted to discuss here is IoT application in terms of shopping. Yes, you might be familiar with that. Nowadays, the many more shopping malls and other things that has been coming up with these IoT solutions. Uh, to some extent, if I'm just entering the doors of this particular shopping mall, I should have a tag with various list of the, you can say, objects that I wanted to purchase from that particular mall. No need to wander here and there where that particular object lies. Once that particular tag data is available, once you enter into the room, that each object will be equipped with a similar kind of tag information, and then that information should be available to you, that such kind of objects are lying at a particular corner of either hall or let's say room, and that object can easily be available to you for purchasing, and so on, right? So once that particular object maybe you can say sold out or get reduced in number of quantities, as far as you can say that objects are concerned in the mall. So that particular information also should be available at a person inside the mall who is handling that particular object inventory, and that person will easily be proceed further to have the certain objects to be kept uh, on the at that particular location. So such kind of you can say IoT application environment might be available as far as shopping is concerned. This gives the personal information about me. Yes, I wanted to have very personal information about me, and many more things. We might not be you can say judging ourselves to some extent. Yes, IoT will definitely will look at that particular as a solution, where you are going and why you are going, to whom you should be interacted, then how long you should speak to your friends, what kind of connections you should have, and how long it take to get that particular work done. What about your messages? What are different types of messages that you should be aware of that? You should be familiar. You should go ahead with that particular messages and so on, right? So personal and social kind of things, that is what really been worked out now as far as IoT network is concerned. This slide gives your current status of future as prospect of IoT. Yes, from 2003 to 2020. See, from uh, as a connected devices per person, from 0.08 is exponentially has been increased within a span of maybe 17 or less years, 6.58. So that means we are now thinking to go with that particular devices. Why not that those particular devices should be IoT enabled? And in coming years, those particular devices should be enhanced over to in a such a fashion that those services should be easily been available and easily been grabbed by the lot of number of peoples in and around. So we have connected devices from 2003. It was 500 million. It goes to 50 billion in 2020 or more than that, with related to the world population. They might be using this particular IoT concept or IoT devices. This you might be familiar with the recent IoT products. Yes, to some extent so what's your the we have the IoT small devices, maybe in terms of switch, maybe in terms of let's say plug, maybe in terms of setting of some sort of temperature, or in the form as in the form of thermostat, maybe in the form of a ninja block as a hardware component that will be really be utilized in order to give a sensing environment inside our you can say maybe an home, or let's say office, which will really work in order to sense that particular data and should be available uh, to the IoT network. So this is what you can say recent IoT products for various application areas. As far as IoT is concerned, yes, we know we should be able to get the smartness. Yes, if it is more smartness, so we will have a more you can say efficient and effective IoT network, right? So smartness may comes with four levels. One is the very passive, may not be have enough smartness. When is required and that particular data is available or communicated, passive RFID or QR code. Then one smartness may be in the form of an active, where you can say actively everything comes into force. Maybe 1 to 4 cents it is called as a called for that. So that means whenever the data and that particular thing that should be communicated, so actively it will start making some sort of sense out of that and make communication possible. Aware is one kind of another level of smartness, where you can say it is a fifth sense. So where a proper action will be decided based on the computation and based on the communicated data that is available to our object. So that is what you can say telehealth situation. Or there might be some sort of object that is autonomously been created, like autonomous car, or let's say a smart grid and so on, where which will use their own rules and regulations, which makes use these particular IoT enabled devices and technology to make their decision properly uh, and autonomously, so that it won't be you can say dependent on either of the object, either of the other technology, or either of the let's say some other data. Now here from onwards, here we'll be looking out the various application scenarios, challenges, research challenges and opportunities. I'll be taking discussing only, let's say, 4 5 6 application scenarios with those research challenges. One is the smart environments, might be healthcare systems, might be smart cities, might be related to the transportation and logistic, might be related to agriculture, personal and social. So let's have a look at the smart environments, where these environments, just now what I had also been was online with Dr. Himanshu. He had given some brief about the smart home environment, smart, let's say, health environment and so on. So we are familiar with this. Now this environment will have some sort of challenges, since we are using a lot of number of devices at our place. So those particular devices has its own capabilities, has its own functionalities and applicability and uses. Then how you will form a network out of that particular devices, right? So that is one of the biggest challenge, where it is called as the interoperability of devices. Now, once I may use, let's say, my laptop, my TV, let's say my mobile device, a CCTV camera, then we have the audio system, we have the, let's say, weather monitoring system, we have, let's say, some sort of lighting system or some other system. How those will maybe integrated together if it is required, or let's say how they have been, you can say, sense the data out of the environment. So that is what you can say, and interoperability of devices. So all the devices should be in a position to automatically or on movement will be sense the environment in terms of sensing the data out of that, and that data should be able to communicate to the other object when required, or to the other part of the network. So in this kind of challenge, we have the interoperability challenge for that. Since we have the vendors from, we have the various devices from various vendors, we have various smartphones from various vendors, we have various laptops and other devices from other vendors and so on. How they will be able to have cope up as far as your devices are concerned. We're not talking about the data and let's say network issues, but we'll be talking about the devices. Now the devices may have a number of issues like technical barrier, let's say financial barrier, may have some sort of requirements as far as reporting of those particular devices are concerned within a network, or let's say some usability of IT services and so on, right? So now those devices may have certain layers in terms of they define some model related to that particular device. Some devices don't require any connection in the sense that they are not been able to connect to the internet, or they don't need internet at all. Still they form some kind of network within an environment, and they have some kind of dissemination of data and information to the other object, right? That may possible or may be required, and so on, right? So in that particular case, there is no need to you can say automate, or let's say make that particular device to be connected to the internet. So how this is possible? May be possible with related to the you can say getting the data from sensors, and they just pass on that particular data, maybe a very small network, maybe let's say a pan, or maybe related to the let's say low pan network, or maybe let's say related to the you can say Zigbee, or some let's say Bluetooth. You can have that kind of networking environment you can use for that. Yes, of course, there are some other devices that may require a technical aspect as a model, where they really will require as a, you can say, connectivity. Now, this connectivity, now for the connectivity to the internet, yes, we require some kind of additional functionality for that device. We require some additional module for that as far as connection is concerned. So you find out that particular model, right? Or there are many other devices that we should be able to give a syntactical and semantic data, or messages, or alerts, alarms, so that those particular devices will be a part of that particular network, and other object will behave based on that particular devices, right? So let's say I have some, let's say a lightning. So I wanted to go for lightning that is only being controlled within that particular environment. So as far as lighting is concerned, that I had to set my lighting and device in such a fashion that that lighting device should get a syntactic and semantic matching alerts related to the environment of light, and then only that particular device or object will be in a position to make the lighting decision, right? So there might be some devices might work in a dynamic environment, or in an behavior, something specified behavior, something should be used as a conceptual device, and so on. So each device has its own capability in terms of low or high, as far as your home environment is concerned, or as far as your, let's say, smart environment is concerned. And related to that particular device, we should have a research challenge is in terms of how to decide that particular capability of a device to be used, how to go ahead with that particular devices interconnection, and how to go ahead with that you can say getting the data out of that particular devices, right? Another important issue related to the smart environment is interoperability among the sensors. Yes, sensor data, what just now we discussed, data should not be loose, data should not be tampered, data should not be misused from the sensor. So with respect to that, what's your the syntactic and semantic issues are there, so that should be tackled in a such a fashion that should be available to all the objects. And if it is required, there might be an issue with related to the integration of this particular data from the other sensors. Another important aspect related to this is privacy and security is already been covered by the earlier experts. So I'm not going into detail with this, but we wanted to have a very secure and private privacy for the data what is there inside the environment, and we should have a proper authentication and authorization techniques. And there are many more threats and attacks that might be possible, as it is a wireless network, and you can say very small network and a very volatile network. So with related to that, we should go identify those particular security challenges. Communication protocols are concerned. It's just now discussed. The communication protocols is related to the device and related to the services that has been governed. And within a smart environment, what kind of services that are meant for that. So you need to identify such kind of services, and then you will go for communication protocols for such kind of services. And whether we can reuse the application for a particular device, let's say for a PC or for a tablet, for a mobile device, for a tablet, or such kind of, you can see, devices that is meant for a similar kind of functionality and sensing data from the environment to some extent, whether whatsoever the application we have in those particular devices can easily be should work with the other device. So it is what reusability factor. Let's talk about the smart healthcare systems. You might be familiar with this healthcare system. Yes. So healthcare system is, you can say, should be handled very seriously and at the highest level. Maybe the environment may be at the personal, or maybe in a hospital, or maybe at the care center, or maybe nowadays what we have the corona center and so on. So might be handled, let's say, from the government, or let's say from the private hospitals, private doctors, or let's say some, you can say some, uh, you can say a number of agencies that is being involved in such kind of healthcare systems, right? So in healthcare, the main issue is related to data. So we have so many sensors that has been, you can say, incorporated into our body in order to get various, you can say, aspects related to various parameters from the body. Maybe in the form of a, let's say, ECG graph, maybe in the form of a, let's say, in the form of a, let's say, heart rate, in the form of a body temperature, maybe in the form of, let's say, oxygen level of a blood, or maybe let's say some position of a patient, or blood pressure and so on, right? So you we cannot have an all-in-one sensor for this, or getting the data out of these particular parameters from the body. So we should use the number of different sensors that can be easily will be available, or will be a part of the body, getting that particular data from the body easily, and will be able to uh, make interconnect to the other object that is related to get this particular uh, data from the patient. So as we said that the patient health data is very crucial factor in terms of challenges. So we should have a security and privacy methodology in such a fashion that there should not be tampering of the data, stealing of the data, should not be any kind of attack as far as data is concerned, or as far as your system is concerned. So we should have a taken care as a very secure, you can say, technique to for that particular data. So this may lack to some extent due to lack of cybersecurity technologies, and you can say number of awareness among the users as far as healthcare system is concerned. Then the other challenge is to enforcement of e-health policies, where we normally be looking at the various e-health policy that has been governed by the government and semi-government through various channels. So now those particular channels should be utilized ICT in a larger extent, so that those are through that particular ICT, this e-health policy should be applicable and should be known to the all the, you can say, persons, which will be really been useful to them. So for that purpose, we should have a people. So now the people to govern this particular e-health policies, in terms of that those people should be involved in order to promote those policies, should be trained, should be educated, should be collaborate and participate in such a fashion that all the details of e-health policy should be known and understood very well to the common person. As far as services and systems are concerned, it is related to the accessibility, reusability of the services, quality of the services, and timely availability of the services to all the people as far as policy is concerned. And so sometimes certain different processes that might be involved, like how to extract the information, how to have that particular information as far as cross-platform is concerned, how to utilize and effectively and utilization of that information as a one process as far as e-health is concerned, and should be a trust model among the users, and should be automatically been available as a service to the people with all analysis of the entire big, you can say it's a big data of health of that particular environment and should be adaptable at any moment, right? Another challenge is timely delivery of data is in terms of analytics of data as far as healthcare is concerned. So we should go ahead with the big data analytics methodology for that. Uh, Another issue is accurate response to critical patients. Yes, we should have a IoT environment in such a fashion that critical patients should be identified easily, so that we'll get the data from that particular IoT enabled device and sensors, and the doctors and let's say caretakers or let's say nurses and other medical staff should be in a position to identify that critical patient at any moment and should be able to monitor that very easily, and so that a proper medical facility should be provided to them, right? Also, the context awareness is one of the biggest challenge where we can go for the awareness of the, you can say, context related to the healthcare. So let's say maybe a particular device should be used with that particular context. I have our IoT enabled device if I am entering to the ICU unit. So that particular device should be behaved as an ICU unit data, right? So it is related to identifying the data that is available in and around from the other device, and based on that particular data, so that particular device should be able to identify the context and so on. So this also will have an interoperation issues related to the devices what we are using in healthcare systems as per their interface standards. Due to lack of time, I will be just covering the other parts little briefly. The challenges in smart cities are huge due to a diversified issue that should be taken care as far as smart city is concerned, related to the transport, related to the traffic, related to the hospital, related to the mobility, related to the commerce, security, and so on, energy and other management like waste management and water management, and then you can say energy management and so on. So number of diversified challenges has been concerned, but here I wanted to focus only on three, like people, because the people should aware that how these particular solutions to them, and they are been involved in terms of identifying the smart environment through within a smart city through those particular IoT devices, and they will be using those particular services for in order to enable their life very easy and uh, fruitful. So the people, that is what you can say, in a position to have that particular environment. Then the second part is institutional issues like government or governance within a city, policy and regulations. So they should be able to identify the very clear-cut policies and regulations in terms of going ahead with the you can say conversion of that particular various issues or let's say parameters as far as smart city is concerned. Then might be there are some technologies issues related to the, you can say, various devices and networking components. Then you can say related to the data processing, related to the data center, related to the interoperability issues and so on, right? So the focus should be given to these three areas as far as smart city is concerned. Then of course the data security is equally important as far as the integration of various services might be there for a smart city environment. Then yes, scalability issue is much more, because the smart city will have a, you can say a focus in such a fashion that the scalable issues should be tackled, and it has to be on a priority basis, right? Because it is a city environment. Then deployment issues might be lack of basic infrastructure, lack of internet services, like lack of you can say infrastructure like connectivity and other support systems. So there might be, let's say, deployment issues related to the services through IoT environment. Of course, smart transportation and logistic. It also includes, you can say, various aspects of IoT. I will be just focusing on the last content. So there are various challenges you can see from this one. Technology challenges, interoperation challenges, political issues, diversification of vehicles and transportation, Then automatic driving also there is an issue for that this, and the number of data that has been generated out of this environment, how to handle that the data as far as big data is concerned, and so on. So here I wanted to just focus on the layered architecture issues related to transportation and logistic, as in terms of you can say four layers. One layer is application layer, where these particular layers might be used for how these particular services should be governed to the number of people in terms of identifying the correct transportation, identifying the correct you can say logistics, and identifying the correct you can say vehicle and goods and other things related to the those applications. Sensing infra layer is also been important as far as sensing of environment is concerned, like your you can say sensing in terms of sensing of various environment, in terms of sensing of cameras, sensing of parking slots, sensing of terminals, sensing of let's say fee collection center, sensing of other terminals, sensing of other vehicle, sensing of logistic tracking system, passengers, their flow, and so on, right? Communication is mobile network. You may have a land of go for various communication aspect in terms of making transportation very easy and efficient. We'll go for communication layers in terms of mobile network. You may have GPS, you may have a GIS, you may have go for Wi-Fi or wired network, or let's say optical fiber network, and so on. Service layer will may have in terms of services for the vehicle, people, and maybe services should be available on the highway and other part of the city or across the environment. Infrastructure, basic infrastructure should be available with this smart transport like GIS mapping services, cloud storage, and you can say computation of that particular data and handling of big data as far as transportation and logistic environment is concerned. Finally, smart agriculture. Yes, agriculture, this environment nowadays is booming, so that agriculture processes and activities is now been should be made as a way as smart as possible, so that there should be less efforts with more productivity, and you can say the farmer should enjoy their you can say efforts and the time, and with more productivity and more profit, right? So these issues are worldwide issues, so that's why we should go for the smart agriculture environment to adapt this particular IoT enabled devices, and you can say objects and network issues in order to solve to some extent various you can say issues related to agriculture. But the challenges are initial setup cost is too may high, right? Because of various machineries and various other things that have really been required as far as agriculture is concerned. So, in order how to go ahead with that particular making that particular object as an IoT enabled object. So initial setup cost may high. Then that there might be physical attacks on the sensors and systems, because since we have a lot of things that is to be done by the as far as agriculture is concerned, we should have go for soil monitoring, we should go for let's say water monitoring, go for humidity, go for quality of air, go for wind direction, and so on, right? So in order to have many more sensors are there, so there might be some physical attacks on the sensors and systems, as it is an outdoor kind of you can say application. Then we need to find a proper sensor for this agriculture, because agriculture is an area that should be governed with a proper identification of sensors as compared to the other areas. Then we should be available with the basic infrastructure as far as technology is concerned, related to the devices, related to the smart devices, related to the smartphones, related to the connectivity, related to the internet issues, and so on, right? Or there may be challenge in terms of diversity of farming process and crops, right? So it is based on the geographical and let's say you can say a farming process uh, based on the area or location. So we that particular challenges is the biggest challenges in order to go ahead with the smart agriculture. There might be, let's say, unpredictable environment or atmosphere or the geographical areas. Finally, the smart personal and social challenges are there. So that whatever the devices I have in and around, so that those devices should be utilized for my personal use and or social use or social kind of you can say activities, and so that to some extent I can just have that particular work in such a fashion that I should you can say get that particular work very smartly. But still I have some challenges with respect to that. It is the interoperability of devices what I am using as a personal use, right? So there is a device management. If I have many more devices for various, how that devices can be managed. Security and privacy as far as the data and you can say processing of the environment is concerned. Fault tolerance is also one of the issue related to the those particular devices, because only one device is meant for one service as far as personal use is concerned. Heterogeneity because of, let's say, various kinds of devices related to the various different functionalities and different you can say an application. So that's a heterogeneity network. And uh, social media, use of social media. So how I can go ahead with this use of social media through you automatically will be done or being utilized by me through my device. So these challenges has been already been discussed at far. What will be the solution for these challenges? So here the three solutions has been suggested as open source development. Yes, interoperability issues can be solved as far as devices are concerned, as far as sensors are concerned, as far as data is concerned. It is so through open source development. Or you can say there should not be any misuse of the data that has been governed in an environment by setting up some standards and regulations by the government and industry, so that that particular standard will play a vital role. And also we should have go for the you can say very strong security systems as far as security and privacy of data and IoT devices are concerned. So it will really will solve to some extent those particular challenges what we had seen in earlier part. Finally, I wanted to go for IoT environment. Just I am ahead of time, just only 1 or 2 minutes I will be extending my session. So the opportunities are lies plenty, right? So we have opportunities in terms of the components of IoT network, in terms of identifying the devices, correct sensors, and going for that particular protocols, designing and implementing the protocols, identifying the objects that should be a part of the IoT network, right? Very smartly. Then identifying the various systems that will really be required as far as automation or you can say a part of the IoT network is concerned. Then the transaction automatically should be done maybe within 10 seconds or maybe less than that. Security will also an opportunity for to go ahead with the that particular IoT network. Yes, in all the areas that what we need a large you can see strong security mechanisms, easy authorization process, preparation in advance. Maybe may like means in the industry sector or manufacturing sector or process management, we can just prepare our device, we can prepare our that with respect to that particular process, so preparation will be a little easy for us. And finally automatic remote control and monitoring. Yes, because we wanted uh, control and monitoring system that is of remote, that is of automatically. So it should be governed through our IoT devices, through our IoT objects is connected to the our IoT network. So that is what we have plenty of opportunities for that. So this ends the topics related to the IoT, you can say research opportunities and research challenges. So I tried to my best level so that through those case studies, through those application areas of IoT, uh, how we will need to understand the various research challenges to go ahead with that. Many more research challenges have already been overcome to some extent, but still, as in India, we may be lagging, and those research challenges has to be taken care very rigorously, as we wanted to survive in coming years as compared to let's say Western countries. And I hope what are the MNCs and the other industry and vendors, they has been coming up to provide such kind of services related to the services and products. And as far as our government policies are concerned, there is work really been required in order to support with those particular services and products to be survive in IoT environment as a global. Okay, so thank you very much for being with me. If you have any doubt.
Thank you, sir. Thank you very much for conducting this wonderful session. Here we have some questions from our participants. Should we take
Yes,
this
ma'am.
question?
Yes, sir. Yes, madam.
Okay. So very first question we have from the Jagdale sir. What is your opinion and suggestion to conduct IoT practicals online from home? Mostly we have used Arduino and Raspberry Pi for our syllabus. So how we can conduct our lab practicals?
As far as our university curriculum is concerned, they are given practicals related to the testing of our IoT environment. As far as my views are concerned, so we are supposed to give the idea to our students in such a fashion that how we can utilize that particular IoT environment to solve a bigger problem. Just now I had given some, let's say, smart elevator. So smart elevator, we cannot have a testing of that smart elevator in the lab, but we can extend that particular idea that how this particular elevator, what we are using, that should be made as a smart. So how the smartness should be provided in that elevator, why we need that, and how we can give that particular smartness. So we have to see the various problems related to the elevator as far as uses of UCC is concerned, as far as functionality is concerned, as far as applicability is concerned, and then we can go ahead with the additional aspect or concept of IoT towards solving that particular problems intelligently. So that way we can have such kind of practicals for our students. So I think you might be making some sort of sense out of my answer. I don't know.
Okay, so we'll take another question. How IoT is helpful to analyze data, either it is descriptive or predictive?
Yes, for this IoT itself will not have that particular analysis part. So we should be able to support our analysis infrastructure to make that particular analysis of IoT data. So, like let's say we have analytics, you can say infrastructure like through your data mining techniques, through your AI techniques, through your ML techniques, and in that particular fashion, we can make that particular data in such a fashion that make analysis of that data will be used for further decision like that.
Okay, so one more question is there. How
Yes.
IoT will have an impact on AR and VR technology in future?
Pardon, I'm not getting.
How IoT will have an impact on augmented reality and virtual reality technology in future?
Mm, I'm not the right person for AR and VR, but as far as my knowledge is concerned, whatsoever the devices we are using for AR and VR should definitely will go for IoT fundamentals or IoT concept in future. For nowadays, those devices are being used as an IoT. So,
Okay.
as far as uses of that particular technology is concerned, is we should identify the uses of IoT that should be really work for that particular AR and VR technology.
Okay, fortunately, we have our next speaker, Dr. Parle. I think he can give the right solution to this because he is in the field.
Yes.
Okay, thank you very much, sir. I think we have done with our question answer session for this particular session number 2
Okay.
for today.
Thank you, madam, and thank you all participants for being with me. So we will have a next session similar to this. Dr. Parle sir is with me. Good afternoon, sir.
Good afternoon, sir.
Hello, sir.
Hello.
Okay, so
Yeah, welcome to this session, sir.
Thank you.
Madam, you can continue.
yes, sir. Thank you, sir. I would like to introduce our next Hello everyone. I would like to introduce our next speaker, Dr.Parle sir. He's having more than 20 plus years of experience in core engineering knowledge. And sir has done his PhD and MTech from IIT Bombay. He was ex-Bark scientist, and he was worked as a principal consultant in Infosys. And he's having a tremendous knowledge on the augmented reality and virtual reality too. And he has undergone with the various medical related IoT applications. And I would like to thank Dr. Parle sir for accepting our invitation and coming here for conducting this live session. I'll hand over my mic to now Dattatreya Parle sir to take over the session now. Thank you, sir.
First of all, thank you, madam, for the opportunity. And I'll try to highlight the use of IoT into healthcare sector, and I'll take you through various use cases and applications. I hope you people are able to see my screen. You are able to see my screen? Hello? Hello? Lisa?
Yes, sir.
Can
It is
you-
visible. You can continue, sir.
Are you able to see, madam?
Yes, sir. We are able
Hello?
to see your screen. You can continue, sir.
Okay. So, as I said, my talk will be around IoT in healthcare, and maybe I will also try to address the question how AR, VR will play a role along with IoT in a healthcare. These are some of the contents I have planned for this session, 1 hour session. I'll briefly take you through my introduction, then IoT, how IoT is used in a healthcare cases, and then I'll talk about there is another emerging technology within IoT called digital twin. How digital twin will help in healthcare, and what are the challenges in using the IoT in healthcare. With that, I will conclude. So, my brief introduction and related expertise. I have, as madam said, I have 20 years plus experience in different domains. So, primarily, I'm a mechanical engineer, so a lot of experience in mechanical product design, development, and all using CAD, CAM, CAE technologies. But fortunately, I have got an opportunity since my MTech days to work in contemporary emerging technologies, then subsequent Baba Atomic Research Center, and then in Infosys. So that led me always to work in emerging technologies. And that is how then I land up into these different technologies and worked for different customers. Then I was also part of a software development, customization, and all. So experiences across product development, services, and R&D, and training, and so on. So the experiences from concept to manufacturing. Recently also, I completed my nano degree from Udacity for autonomous systems, self-driving cars, and all. So the learning goes on. These are the technological expertise which I acquired over the years. In 20 years, different tools and technologies required for working in either core engineering or emerging technologies or in information technology. So I had done a lot of work in healthcare domain, and primarily when I was in Infosys, modeling and simulation. So I was instrumental, or I was a key person to establish medical device service offerings using modeling and simulation for various customers. We have done a design and modeling simulation of various medical devices like CT scan, MRI machines, or simulation of respiratory systems, designing different implants, and all the pictures which you see here, almost all work is done by me as part of, and most of these works are award-winning works. So then during Infosys, I got 4 consecutive year excellence awards, individual awards for my contribution in various domains. And 2 of the awards I can definitely say were for my healthcare biomedical engineering related work. Then my work in biomedical engineering also was considered for a nomination to Golden Peacock Award, and then I also got various best paper awards, simulation awards, and so on. So that's how I did. These are some of the more details. I'll be talking about this specific work with respect to IoT, how it is important. Then these are the other, we created several human organ digital models to study various aspects into it. Start smallest from the dental tooth to the as complex as a human skull, and so many. So we were winning best paper awards. We were there in one of the company's desktop calendar for 5 consecutive years, and many other recognitions for that work. So then I was also part of developing a lot of products, and some of those products are available on Amazon. Due to this COVID situation, we have stopped selling because of the supply chain problem. But soon these products will be available, and we are known for manufacturing these products, low cost virtual reality products. So these products, this is one of the products which we developed. So virtual reality made easy, and this is just 200 rupees product. We are India's lowest price selling technological product. Similarly, if any of you are interested to make these products, we have enabled them to buy DIY kits. They can buy. In fact, madam was there. In fact, we conduct this workshop in our office, but then now ruling out for some time, we are enabling people to do this experience at home. And then we also printed 3D printer is here just behind me. Then we started creating a plastic ones. Now this is a unique design, without joint, multicolor, tricolor design, and so on. So this is how we have been creating several products. So we typically go through this product life cycle. We follow. We started with the concept, then optimizing, then refining the product, and then sales and marketing. That's what. So we have the SL World as the largest customer who bought almost 1,000 units, and then this product is recognized by business standard, our 200 rupees product, and because the price, because the way we made it available, and it says that on one side there is a Microsoft who sells $3,500. On the other hand, Dr. Parle, who retails it just for 200 rupees. So that's a tremendous recognition, I will say, for our efforts to bring this technology to the most common. Now, this technology can be used by anyone. Those who wants a smartphone, what you need is you should have the phone. Then think like this. You want to, let's say, go on the moon. You can just download some app or create your own app. Start that app, put this phone inside, and then start looking. I'll just anyway show how it is used in healthcare and IoT combined together. And then this product won recently the Best Innovative Product Award at Aurangabad exhibition, where 400 companies were showcasing their. So we made this technology. Our buyers are around India, from small villages to big cities. So we have made this just low-cost technology available. Now you might wonder how this, what this can do. Probably this video can partially at least answer the question what a participant asked in earlier session. So this is the kind of device this doctor is using. I can see it from the front. So they could save a baby's life using visualization created in using a cardboard. Within they realize that from their 2D pictures, 2D scans, that they were not able to make a decision whether that operation can be done or not. But converting into 3D and making them to view through this device enabled them to understand more details of the heart, and they were able to make a decision of a surgery, and then the kid was saved. So that's the impact this simplest device can make into the life, and we brought the cost very low. So as I said earlier, you can either buy ready-made or you can buy DIY kit. You can use it beyond that. You can use it for variety of purpose and all that. So training, learning, maybe connecting. Maybe you can think you can connect IoT device to your mobile. In the app, it can have a VR app, and the data which is coming from IoT can be shown into. So what will just take an example of this heart. Now imagine if I can show some ECG graphs of heart on the this model. So this will give a more immersive. So I can connect, but then you will have to do that connection, do the programming. That is how you can probably make it. So in line with that, that was one benefit. Probably another benefit which I can talk about using a VR is today you don't have this in IoT in healthcare. Probably you see this kind of graphs, visualization. Now in a mobile, you are, let's say your wearable will show how much temperature, how much heart rate, how much steps, how much are. If you go to the hospital, even it is a smart hospital, it shows you this this kind of information, right? Blood pressure value or something like that. But it really doesn't give that immersive feeling. But with the VR in place, let's say take the same example of the heart. I create a heart model, but if I want to see the blood flow of or blood pressure information in a more immersive manner, then you can do that. There is an app, let's say Living Heart Project, and then you just start that app. Then this will convert into this kind of screen. Once that converts into this kind of screen, you have to put that into the simple headset like this, or it can be very advanced headset. And then that headset, you will see as if the heart is kept in front of you. You are seeing all attributes of the heart as if you are seeing in real in front of the heart. So this is what you can see. So I think I will not able to show because I was looking in this direction. So that's something VR will bring. These devices can bring. So then now coming to our main topic. So IoT. Briefly, earlier speakers anyway might have given you the brief introduction. I'll quickly go over with that, and then I'll switch over to some use cases and applications. So what is IoT? I need not to define it. So anything to everything connected to the internet probably is the simplest definition. Why this IoT is important today? Because a lot of use of internet and connectivity in the devices. So by 2025, one of the study predicted that almost $27 billion devices will be connected. Maybe by 2025, almost 2.2 billion mobile devices will be connected. Or in terms of money, if I have to talk, it is probably a $3 trillion economy or money on the table and so on. So that's the importance of this, and it is growing day by day. There are a lot of opportunities and challenges. So there are 4 building blocks for any IoT application: sensor, connectivity, data processing, and user interface. Once you have these building blocks, once you connect them together, that forms your IoT application. So going into the little bit detail of IoT architecture. So if you say there are things to be connected, or peoples to be connected, devices to be connected, whatever, or systems to be connected. So we have a device layer, and this is connected through the sensors and gateways. Then you have a communication layer. This communication layer can be short range, long range, or very long range, depending on the kind of application benefits you want. And then once you have that data from sensor to be communicated to which is a middle layer, a platform layer, which is a more of a application and all. So you take all the data, do a lot of processing on that. You will have to ensure all security aspects, all other aspects, and then if you need to implement AI ML into that, you have to do that. And finally, user will have only this. So user will see reports like earlier slides I have shown, and then some dashboard kind of thing, or user can do some actions and so on. So all that will be there. So this is a typical architecture for any thing to everything in IoT. Depending on the applications, probably your sensors may change, probably your things may change, probably your communications may change, probably your middleware will change, and things like that. Lot of applications in the earlier lecture only, sir was telling lot of things, right? So yes, one of the application is probably the IoT. And IoT one of the application will be healthcare, and how healthcare is benefited from IoT. So let me begin with that. Use cases, some of the use cases which I was part of, some of the use cases I just picked up from my earlier companies and just wanted to show you. So in application, in IoT, applications of IoT in healthcare, the application can be across the value chain, not only just in healthcare, but across the life sciences. It can be in a lab, R&D lab, or it can be in a manufacturing stage, or it can be in a supply chain, or it can be in a patient care. So I will talk about some of the applications across this, except manufacturing. Maybe some application in R&D, some applications in supply chain, some applications in patients. And to be very specific, IoT is not new. Everyone is a part of that, right? Most of the participants probably might be wearing these kind of these devices. Fitbit probably is the simplest IoT device. Smartwatch is another simplest IoT device, which is already monitoring the personal health. Personal health care is there. Now, this Fitbit can give you a lot of data, how many steps, how much exercise, what is your weight, what is your height, all that can be integrated, and personal health care. Similarly, these smartwatches are becoming smart day by day in integrating a lot of functionalities. Beyond that, now slowly these devices are becoming the part of your life, part of your, like maybe a glucometer at home, or ECGs at home, or different small devices which have the connectivity to the internet. And you can have those kind of devices at home, either through the Bluetooth or USB or different kind of communication. It can connect to your mobile phones. If your hospital or if your doctor can allow you their system to connect. Then we have doctor also on call. Whenever you have, doctor will know what's happening with a particular patient, and that's how the things are moving. So today already healthcare, personal healthcare, IoT has made a difference to your life, right? You can probably it also benefited me because I could track all my activities because our job nature is sitting and all that. Then one of the use case which I was part of this in my earlier journey, we implemented a baby health monitoring system using IoT. Now I talked of personal health there. Maybe I will now talk about again another personal health care probably, but having a broader scope. Now we were asked to develop a sensor which is a more like a Raspberry Pi size of system, not beyond that, and which should have a lot of capabilities. So basically this requirement came from one of the diaper manufacturing company. They said they wanted to build, some system which will help people to use with their diaper and enable them to be, because people will, in most of the Western or developed countries, people normally use the diapers. So diaper is an integral part of baby's life, let's say. Now, if I can put something, some device on it, which can connect to the internet and can tell me probably what baby's status is. Now, in all these developed countries, the houses are big. Baby is in somewhere in some bedroom. You are sitting somewhere in the garden, and maybe probably you are worried. How is baby doing? So with that requirement, we developed this system and showcase the usefulness of this system. So being that company a diaper man, they were not very clear what need to be done. So I did a lot of research. I talked doctors. Fortunately, most of my family members are doctor except me. I'm a doctor of a machine. All others are doctors of a human being. So that helps me a lot to think out of box and come up with the different solutions. So this solution, because then this was further closer to my heart, because my wife is a pediatrician. So I had to talk to her, get her viewpoint. What does a baby monitoring typically means? What should we do? Then she told me all that, like you need to monitor a sleep, you need to monitor a feeding, you need to monitor the activity, you need to monitor the temperature, you need to monitor a lot of parameters came. So we decided what are the parameters to monitor, and then we decided initially do this with the Raspberry Pi, and then develop a custom sensor system. We also suggested motion sensor, vision sensor, and all that. And then this sensor will be mounted on a diaper, and now a lot of data, there will be a card system which will be connected to your app on your mobile phone, and then the data will be stored either on the card or maybe on the cloud. We had a discussion around it, because if we store on a cloud, there may be some challenges in terms of security, and also we decided to do it on a card. And then, but still there was a challenge. I mean, customer was still not convinced whether how it will tell it my baby is comfortable or not. How these parameters. So there was a big question. What do I do with that data, right? So I suggested them. I came up with the terminology called baby comfort index. I told now a lot of these parameters will develop a factor which will vary from 0 to 1. If 1 if that relationship gives me, if all these parameters are not exceeding your threshold limit and but varying somewhere between the threshold limits, then it can give me then I will establish a mathematical model. That mathematical model will convert the data into either 0 or 1. And then 0 means there is a problem or there is a threshold we can keep and all that. And that is how this system was showcased to the customer. And this is one of the first-hand experience I'm just narrating. So there were a lot of challenges in terms of all, how you want to do all that. And then there was a challenge of gathering data. How will you build the model? So we generated pseudo data using Monte Carlo simulation technique and all, and then created a mathematical model and so many things. So without going in much detail, maybe I'll talk about another example, moving out of the home now. So this is another application to which I did a consulting where they are developing a virtual football coach. This company is developing a virtual football coach, integrating a lot of technologies, vision system, different type of sensors. Now player will have different type of sensors like monitoring your blood flow, motion, all that. And then we decided at the end, when the player plays on this machine for a certain duration of time, it will tell how good or bad he played. On top of it, what was his health status, whether there was too much of strain on his body or so many other parameters, or then it will continuously keep monitoring his different physical activities and all that, and then that will tell. So this was another engagement which I did. Then coming to the another example, now moving again out of the home, say. Now recent, you might have seen lot of cities, lot of developed countries are now coming up with in earlier session also, sir was telling smart hospitals, smart cities and all, right? So now these smart cities are building smart hospitals, smart clinics, and that's there already there. I'm not going into the nitty-gritty. So I just came across one of the application in Dubai where they are absolutely smart hospital. You go with your as a, let's say, tourist, you go there, you have your passport, scan passport, I mean, absolutely no personal, all connected through, then it asks you certain things, you have to just enter the data, then it suggests you where to go and all, and that's something. Then by the time you reach to the doctor, doctor already knows your everything, and then you get a more better value from your consulting doctor than you do manually explaining and all that kind of. And then again, keeping this COVID situation in mind, recently, probably couple of years ago rather, if some doctor would have suggested, I'm offering a teleconsultation or a telemedicine, at least in India, most of the Indians should have said no. They prefer going to the doctor. But because of COVID, now telemedicine or teleconsultation has become more adaptable. A lot of people are adapting, and we can probably, now the question is in future whether doctors and as well as public will trust this system or not, because there are a lot of challenges, maybe because our infrastructure not there yet, we are not matured in terms of infrastructure and all. Initial investment, like sir was mentioning, the investment is there and all. So a lot of challenges are there, but yes, we are going there. We are trying to build our use this into building smart clinics and hospitals and all. So Maybe another application which is again within my house, I will say. My brother-in-law is a radiologist. He works in UK. Now there is a emerging trend in radiology called teleradiology. Now there is a teleradiology is one of the growing trend because of the one important aspect is lack of expertise. First of all, not many expert radiologists available. Moreover, it's not in India. It is a very little different culture, work culture. In developed countries like US, UK, a different culture. So you have stipulated duty hours. If you have to perform duty during that period. If you finish your duty, you can go enjoy your life. But maybe a different scenario in India. But now imagine a situation: radiologist is not there in the night or in odd hours, or there are a lot of radiological reports to be done. How do you do? So now these countries have come up with something called teleradiology. So all your machines, all radiological machines are already advanced now. They can connect to the internet, they can connect to the edge devices, they can connect to the lot of different devices. And then let's take you take a CT scan or MRI, send it to your PAC server, right? And the PAC server is connected to the consultants, doctors, and archiving systems and all that. So now my brother-in-law many times sits in a home and do this radiological reporting sitting at home. This is possible because of this IoT enablement. Now the machines, radiological machines, are connected to the internet, as well as they are provided with the special systems which are also connected with now. The device also is much advanced. Now this can be used on a workstation, or even in tab, or even in a handheld devices or laptops and all. But they are more secured, and also comes with like they need not to type. I mean, speech recognition systems comes with that and all. He just dictates what he observes in the images, and then that is being immediately within an hour probably he completes 3-4 reports, goes back, hospital knows immediately what is the recommendation of a radiologist. So typically this implements HL7 level of kind of requirement, ISO communication model. And also you will need to be careful about, so I observed his system during Diwali. I was there in UK. So you cannot connect anything. You cannot even take anything out of that system, or you cannot send anything from your side except what doctor narrates or writes. Beyond that, you cannot do anything. So that is a kind of system. So IoT definitely plays a major role in such kind of system. Then another example from my own experience. This is again coming from my own experience. And what we did into this is we tried to build a system for a fertilizer or insecticide manufacturing company, where we tried like today, like a corona situation. Few years ago, there was a Zika breakout everywhere worldwide. There was a tense situation, and it was more because of mosquito spread disease. And then an American company came up with the requirement: can we develop an IoT systems for home users, which will keep track of, or a public levels, which will keep track of mosquitoes, and if mosquitoes of a particular type are increasing into that area, then pests will be released. So what we suggested, I did a complete research of this problem. Then I came up with the two situations. I said we will monitor vision system, we will use like this. And then we will identify which of them are mosquitoes and which, then there are different kind of mosquitoes, which a particular type of mosquito only causes a Zika. So then we built image processing system, then we built machine learning algorithms to identify what type of mosquito it is. And if in that area or in that zone, if Zika kind of mosquitoes are increasing, then a control system will activate the pest control. So this was another end-to-end application which benefits healthcare in public. So I will not go into the details. Then we use this deep neural network. We trained it. Then we got right. So a different kind of animation. Just if someone is having doubt, I can just refer to this. Then again another probably recent application from a government of India. They have built a Arogya Setu app, which uses two data from your mobile system, GPS, and your mobile connection, internet connection, which, and then your own input to this device, whether you are COVID infected, not infected, and all. So this device will tell you if you are entering into COVID zone or non-COVID zone and all that. So maybe a brief video. Let me just if you are.
Arogya Setu app, India's main contact tracing technology, was launched on April 2nd this year. The app was developed by the National Informatics Center under the Ministry of Electronics and Information Technology. According to NITI Aayog CEO Amitabh Kant, it has become the world's fastest app to reach 50 million downloads in just 13 days. Arogya Setu is designed to keep track of other app users that a person came in contact with. It then alerts app users if any of the contacts tests positive for COVID-19. The app uses the phone's Bluetooth and GPS capabilities. It will keep a record of all other Arogya Setu users that is detected nearby using Bluetooth. It will also use a GPS log of all the places that the device had been at 15-minute intervals. These records are stored on the phone till the time any user tests positive or declares symptoms of COVID-19 in a self-assessment.
So that is how you can see how people are trying to connect the devices and come up with the different solutions for different. Now, recently, I came across this. Infosys has implemented thermal scanning system for monitoring corona related infections in their employees. So let's see what is that.
Infosys, a powerhouse of innovation, has helped global enterprises swim the tide and be resilient in the current trying times. As the new normal sets in, these enterprises are now preparing for return to workplace for its workforce by adopting a safe and secure approach. While taking various precautions, they are also focusing on elevated body temperature or EBT screening of its employees. This helps to detect infections and prevent them from spreading. EBT screening is also being increasingly resorted in public places like airports for safety. One of the most commonly used screening mechanisms is the handheld thermal scanners. They, however, come with certain drawbacks such as need for manual operations, operators' exposure risk, high cost of lapse and queue build-ups. Automating the screening process to detect illnesses, thus, the need of the hour to make the process effective. Existing solutions available in the market that screen in bulk often come with flaws like skewed measurements due to closeness of multiple sources of heat, reduced accuracy due to reflective surfaces and stray emissions, incorrect data as inner body temperature not captured, inaccurate reading due to wide distance between the individual and scanner, inability to capture temperatures near tear ducts which best represent body temperature. The perfect response to these challenges is the Infosys thermal screening solution. A completely automated solution, it detects the elevated body temperatures or EBT using camera equipped with thermal sensors. This is achieved in a smooth, unobtrusive manner with employees or customers walking one behind the other maintaining a safe distance. With smart AI models, The head is isolated to extract features and identify key regions, including tear ducts, which are critical for EBT measurement. All images are processed.
So again, interest of time, but yes, this is another solution. Then I also made a statement in the beginning that it is also being used in a supply chain, and Wipro has developed one of the solution for a supply chain. Now, this is during the supply of drugs, critical drugs, which is to be maintained at a particular temperature, and so that they are usable by the time they reaches to the end solution and all. So this actually solution was built using two technologies together, IoT and blockchain. Let's see what that solution is.
For most industries, disruption is the new normal. For the global pharmaceutical industry, it is even more so. With compromised patient safety, drug wastage, brand protection, and siloed products, the challenges facing the industry are not just numerous, but complex too. Until now. With the advent of IoT and blockchain, pharmaceutical companies can now dramatically improve patient safety, reduce waste, and preserve brand reputation. So, how does it really work? Let's take a look at how your supply chain manager and your shipping specialist can deploy blockchain and IoT to transform the entire supply chain. Once the shipment manifest is created, it gets automatically logged into blockchain. Next, the shipment is tagged with IoT sensors, with the Wipro Secure Cold Chain solution allowing 100% visibility up to the individual product level, giving you absolute peace of mind. Across air, sea, or land, your shipment is tracked on a near real-time basis with parameters that also include product health status. All the way till delivery and even customer purchase, the system alerts you for any change, ensuring it reaches speedily, safely, and securely. Even the customer can instantly check the drug's authenticity on the Wipro Secure Cold Chain portal. And because all alerts are logged into blockchain, it creates records to ensure never-before transparency, traceability, and accountability. Wipro Secure Cold Chain solution is built on Microsoft Azure's trusted cloud platform and brought to...
So that was another great example. Now, maybe quickly I will touch upon one of the important topic, digital twin in healthcare. So what is, first of all, let me define what is a digital twin. Digital twin is nothing but a digital replica of some physical system, physical product, physical person, physical service, physical process. So think like, let's say, a cloning a system, right? And how it will be useful, I don't want to go into the much of the details, but that's how it is important to understand. So what we did, I already talked about this, right? We built a heart model, digital heart model for modeling and simulation, and which has already won a lot of recognition to me. But we also got collaborated. So I was a key person to do that collaboration with a Dassault System, which is developing something called a Living Heart Project. You can go on Google and search Living Heart Project, and then you will see Infosys is one of the key partners to that project. Now, this project is very ambitious project, which want to make a more realistic heart virtual model. Now, next step probably is building a digital twin. I mean, now it is just a virtual today. When you connect it with the sensors, then it can even become a digital twin. Now, digital twin can bring a lot of value, and how I will I will talk about here.
Imagine a future where personalized healthcare will provide every individual the right type of care in the right way and at the right time. Imagine that every patient has a digital twin a virtual representation of his health status. Let's explore how this could play a significant role when Mr. Clark, who has been diagnosed with atrial fibrillation, is seeing Dr. Sullivan, his cardiologist. Although AF is a highly prevalent disease, it can be complicated to decide on the individual treatment strategy for a patient like Mr. Clark. This is where his digital twin comes in. It starts by using Mr. Clark's medical data to create a patient-specific biophysical model, including a virtual version of his heart, which looks, behaves, and reacts just like the real one. Through a seamless flow of data and advanced analytics capabilities enabled by Philips Health Suite, Dr. Sullivan can connect Mr. Clark.
Now imagine currently only doctor is able to view 2D data. There is no 3D visualization, but this kind of digital models, like what I showed, a virtual twin, can be integrated with your IoT system and can give doctor or a person more immersive information or more immersive detailed information for diagnosis and treatment.
Of digital twin with intelligence on similar cases and select ablation as the therapy with the best possible predicted outcome for him, both on the short and on the long term. Dr. Sullivan carefully plans the procedure by simulating various ablation scenarios on Mr. Clark.
Now, that's not just the case, just monitoring and visualizing the data, but doctor can try it out different things virtually and think if they should inject this drug to what level, what will happen, and digitally this can be seen in a virtual heart, and then they will know whether that has right impact into the treatment or not. Or similarly, imagine another situation, let's say you want to do the stenting. So different sizes of stents will come, different manufacturing stents will come and all. Now, a lot of research has also been done using that Living Heart project. If you inject a stent of a different type, how it behaves. And all that trial and errors, virtual trial and errors can be done to make your diagnosis and treatment a successful one. And you will have a less scope for error. So that is how the digital twin, the more value of a digital twin comes from this. You can have a lot of what if scenarios, and you can save many more lives than normal scenarios. So IoT and VR, if they come together, they can have a further more value. So digital twin can be within a VR or without VR, doesn't matter. But then digital twin is a digital replica of a physical system as it is. So again, I just cut short that. Then maybe briefly, I just want to touch upon, because almost time is up. So what are the challenges in a healthcare of implementing IoT? So I already talked about IoT in healthcare, different use cases at different levels, how it is being used. IoT with blockchain, IoT with AI, ML, that is also being done. And now, but even though that IoT is growing, but IoT has a lot of challenges to overcome. So some of the challenges, key challenges which they need to overcome is privacy and security. Most of the people across the globe are worried about their privacy. And I can give one example, probably one example which recently came across, but not related to healthcare, but similar situation can happen. In a Arab country, one of the drone has did a blasting, and the factory caught fire and all that. So that was that's all, right? So imagine if someone is in, some patient, imagine a situation, some patient is implanted with, let's say, a pacemaker device, which is having a connectivity with, let's say, doctor or patient, which is connected through the internet. Now hacker attacks that and stop that pacemaker. there is an end of life. So that's all. I'm just trying to show you the seriousness of this particular aspect in a healthcare. So one has to be doubly sure that it is not going to breach any safe privacy and security of a particular thing. If there is a slight chance of that, then you should definitely think over and over. That is why the Wipro implemented a blockchain, which is difficult to break that security aspect. Similarly, the way day to day we are struggling with malwares, viruses in our own devices, smartphones, tablets, laptops. Imagine in such device, one malware enters. That creates a lot of problem. Not to the patient, if the system is manipulating, let's say, managing the big hospital, that will create a huge problem, right? I mean, you will not able to monitor the patient, you will not know what was being done and all that. So then there is you need to do a proper calibration. Accuracy is more important. If you are not doing that calibration, accuracy properly, then again you are in danger. And then as earlier also sir said, cost of technology is as on today is a prohibitive. So we need to, these are the basically major challenges I will say, but beyond that there are many other challenges, like there is a heterogeneous devices, different type of data is coming, then a lot of other those challenges are there. But beyond that, I talked about the core challenges. Then infrastructure readiness, as I said, country like India still need to bring that infrastructure to a certain level so that they get a proper, they can implement this kind of system properly and all. So these are the other challenges. I will skip, but yes, I just thought if someone want to know how to do, probably to begin with, the Raspberry Pi is the best thing. That is what we did initially with our baby monitoring system. And once we did that baby monitoring system with the Raspberry Pi, then we develop our own firmware. And then, so skipping this information, everyone may know, but I just thought that may be the best thing to start. So conclusion, so that's with my presentation. So to conclude, IoT is definitely disrupting the healthcare life science industry. I have not talked about a lot of life science examples, but yes, it is disrupting there. Then if IoT is coupled with many other technologies like AI, ML, VR, blockchain, it will further bring a lot of value to these industries, doctors, pharmacists, drug manufacturers, device manufacturers, and so on. And yes, there are several challenges to overcome, and that is where research will come to play. So a lot of people, whenever there is a challenge, I normally say that is an opportunity for a research. So you can do a research, and to begin, you can just start with a Raspberry Pi or Arduino or this kind of devices, and you can definitely build your own basic healthcare, personal healthcare system. And that's it from my side. If you have any questions, I would like to take up. Thank you again, college. Thank you, madam, for the opportunity. And anyone interested to do internship and all, the numbers were provided, madam, and all, you can contact me. Thank you.
Thank you, sir, for conducting such a wonderful informative session. Here we have some questions from the participants. So can we go ahead to take some participants, sir?
Yes.
Okay. The first question is, which security techniques are used in IoT? Chaotic encryption. Hello?
Which security technique are used in IoT? Hello?
Yes, sir.
Are you able to hear me? Okay.
Yes,
Which
sir.
security techniques are used in IoT? Is chaotic encryption is applicable in IoT? I'm not a security expert, so probably I may not able to answer this question, but yes, different security techniques are there. One can implement, but only thing I can only say here is implementing security. Any security is very, very important, and the security is such that it should not be breakable. That is the most important task in IoT in healthcare, but which probably I may not to tell you whether it is applicable or not. I'm not the security person, so.
Okay, sir. Another question is, can you discuss on health hazard due to IoT devices, or can you discuss on health hazards due to IoT?
Yes. I mean, one of the example I remember, I mean, I may not say all all devices will have health hazard, but one example I can give, there may, one need to do this assessment always. One example I can say is, say some CT scan MRI machines. Now, and then you are, let's say, some device or some sensor which has a magnetic field generated, imagine. Now, another example I can give is, now if the patient is with a stent or the patient is with some pacemaker or something, now this magnetic effect might affect the patient's implants. So that is what one need to do, assessment. So I can't specify at this point of time whether a particular device will have any hazard on a particular patient or not. That has to be considered case by case basis.
So one more question is there. Does IoT apps can be useful to check COVID-19 testing if the affected person don't have any symptoms of this virus? And if yes, okay, so another question is related to that itself. If yes, then how it can be implemented or make it feasible? Please share your ideas on it, sir.
See, I see one core part of, you can say, is the sensing for IoT. If you can sense some information, then only IoT can become a successful, whether it is a direct information or indirect information. Even if it is a, let's say, if he is not showing signs and symptoms, whatever the test today we are doing, through that, if we can connect our IoT system to that test kit, even he is not showing signs and symptoms, still your IoT able to predict whether that patient is positive or negative, and then that can be used. So that is how probably you have to do if he is not showing the signs and symptoms. If he is showing signs and symptoms, which can be monitored, let's say, through thermal scanner, the way Infosys has done, that is also another way. So maybe you will have to think what way you want to do, what level of sensors you have and all that.
Okay, thank you, sir. Another question is there. Is there any software to work for digital twin concept?
See, digital twin is a concept. Underlying technology is only same like IoT. But now digital twin brings visualization also, more like 3D visualization. So then there are CAD softwares, there are many other software, like maybe you can use a Unity if you want to bring a visualization in a VR, or you can use their in a AR. There are company like ThingWorks, PTC, ThingWorks. So there are many. So what is that application for a digital twin will govern your selection of a technology. But underlying core technology remains same. On top of this, visualization and what if scenario analysis can be done easily.
Okay, thank you, sir. I think we have one last question from PC, sir. Which standards are to be followed in healthcare? Which standards?
So, healthcare has their own standards, but again, like for example, I said communication layer for PAC system. So different systems, I'm really not aware about specific, but for a communications layer for radiology was a HL7 kind of standards. So to develop a packs or to develop sensors, to develop your application, one need to, again, then there is a class 1, class 2, class 3 devices. So where your IoT application, depending on the standard applicable for that, you will need to use.
I think we don't have any more questions from the participants, sir. And I would like to say thank you from MMCOE and Computer Engineering Department. Thank you very much, sir, for joining us here and accepting our invitation. That is one more thing and important thing here. Thank you very much, sir.
Thank you. Thank you. Thank you. Bye.
Thank you, sir. Now I request all the participants to fill the online feedback form whenever we'll be sending on your WhatsApp group. Along with that, it is mandatory to solve the quizzes, and attendance is also mandatory for getting the certificate. At the end, we'll be circulating you certificate in the next week, in the working days, on your registered email IDs. Now, I would like to hand over the session to Dr. Chaware, sir. Chaware, sir.
Yes. Not the session. Just I wanted to talk a few minutes. Very good evening to all participants and other fellows. I hope within these 5 days, you might have faced many more, let's say, problems, technical difficulties for attending the session. We also face many more problems, but we found some solution. Now you have to identify where the IoT solution is available for this. Right? That is your job, your research opportunity, your research challenges. First thing. And finally, I wanted to would like to thanks all participants for showed your interest towards this FDP. Such FDPs is actually in our department used to organize every year in either of the areas, data science, IoT, then machine learning, AI, and other areas. So you kindly give your feedback so that those feedbacks will be really helpful for us for further improvement. You kindly make your suggestions, and what's your the processes are there, you kindly fulfill that in order to get the certificate will be issued to all participants, those who had registered and those who are having the given the registered email. Certificate will be sent to them by Monday at the most. But we wanted all the data from all the participants as far as your attendance is concerned, as far as your feedback is concerned, as far as your quizzes are concerned. So these three parameters are more important to us, and I hope you will be happy and you will be eager to have such kind of FDP in future from our side. We will try our best to have such kind of FDPs, and similar kind of platform will be available to you for as a learning things. Thank you very much. I also thanks all the experts for showing their interest and giving time to all of us to have such kind of such a nice sessions online. And thank you all. And I finally thanks to our management, principal sir, HUD madam, and all of my team, those who had worked very hard, and to have such kind of online sessions, it was not so easy. I know Sarita madam and Asma madam really work hard to have such kind of you can say collaboration and coordination among
Okay. Thank you everyone for your kind support and your feedback all the time. You have given a very good feedback to us, and appreciate and thank you for appreciating us as well. I would like to say thank you to all the staff members who work hard for this FDP, for conduction of this FDP, and speakers, and you all the participants. Without you, it could not be the success. Thank you very much, everyone. Thank you for participating in IoT FDP. Thank you, everyone.
Okay, thank you from my end as the coordinator of this FDP. Thank you all for support. Thank you. Thank you so much. We are leaving you now. Thank you.